portion on inside. So here light gets reflected from outside the surface of a part of hollow sphere. Light gets reflected from inside the surface of a part of hollow sphere, that is concave. Cave means actually inside. Okay. So if the light gets reflected from outside the surface of a part of hollow sphere, that is called the convex. So this is convex mirror. So this is concave mirror, this one is convex mirror. Okay. So what is the meaning of pole? Pole means the center of the reflecting spherical surface. The center of the reflecting spherical surface is called the pole. What is the meaning of pole? Pole means the center of the reflecting spherical surface. So this is center of curvature. So this is a pole of concave mirror. This one is a pole of convex mirror. So this is actually the center of curvature. Symbolic representation of pole is capital P. Symbolic representation of the center of curvature is capital C. Okay. So what is the meaning of the center of curvature? Center of curvature means that is center of the sphere. Center of curvature is center of the sphere, but the given mirror, that is a part. So listen to me carefully. So what is the meaning of the center of curvature? Center of curvature, that is center of the sphere. Center of the sphere, but the given mirror, that is a part. Given mirror is a part. Center of curvature means center of the sphere, but the given mirror, that is a part. Okay. So this is radius of curvature. Radius, P to C distance. This is radius of curvature. Symbolic representation is capital R. So radius of curvature means that is the radius of the sphere. Radius of curvature is the radius of the sphere, but the given mirror, that is a part. Center of curvature, center of the sphere, but the given mirror is a part. Radius of curvature, that is the radius of the sphere. Radius of curvature, that is the radius of the sphere, but the given mirror, that is a part. Okay, right? So the next very important term, that is principal axis. A line that is passing through pole and center of curvature. A line passing through pole and center of curvature. So what is this? That is actually the principal axis. A line passing through pole and center of curvature. So this is the principal axis of this convex mirror. So this is the principal axis of the concave mirror. Okay, so right. Now let us consider ray of light. So that is incident parallel to the principal axis. So this is a ray of light. Okay. What is the meaning of ray of light? A straight line along which light can travel. It's called a ray of light. So, whenever a ray of light is incident on the silver surface of the mirror, that is parallel to the principal axis. Actually, after reflection, it passes through a point on the principal axis. Actually, that point is called the principal focus. Okay, so this is the principal focus. Now, this is actually the incident ray. Let us consider this one as the point A is the point of incidence. So, how do you draw a normal at point A? So that is very, very important. How do you draw a normal at point A? Just draw an imaginary line from C to A. So this is actually normal at point A. A line joining from any point of the mirror to its center of curvature. A line joining from any point of the mirror to its center of curvature, that will be the normal. A line joining from any point of the mirror to its center of curvature, that will be the normal. So the angle made by normal to incident ray, so this is angle of incidence. Okay, the ray turns back into the same medium at the same angle. So this is angle of reflection. Actually, this ray obeys, the reflected ray obeys the second law of reflection of light. Angle of incidence, that must be equal to angle of reflection. Okay. Now let us consider one more ray of light. So that is incident at point B. So now B is the point of incidence. So this is also parallel to the principal axis. Okay, so this ray is also parallel to the principal axis. This is a ray of light. This is parallel to the principal axis. So after reflection, this one is also meet at a point on the principal axis. So that is the principal focus. Okay. So actually, concave mirror converges the parallel beam of light. This clearly shows, right? Concave mirror converges the parallel beam of light after reflection. Suppose a ray of light is incident like this. Okay, passes through center of curvature, incident at point P. So in this case, the piece is a normal. Actually, here ray of light incident normally. If the ray of light is incident normally, the ray retraces the same path. So in this case, angle of incidence is equal to 0, angle of reflection is equal to 0. Okay. So concave mirror, that is also called the converging mirror. Concave mirror, that is also called the converging mirror. Why concave mirror? That is also called the converging mirror, because it converges the parallel beam of light. Concave mirror converges the parallel beam of light. Okay, suppose a ray of light is incident on the silver surface of convex mirror. Ray of light is incident on the silver surface of convex mirror, and this ray is parallel to the principal axis. So after reflection, it appeared to diverge from the focus. Actually, this is called the virtual focus. Okay, so now consider one more ray incident at P. Okay, now P is the normal. Actually, ray incident normally after reflection it will trace the same path. So ray of light incident like this. Okay. So ray of light is incident on the silver surface of the convex mirror, and this ray is parallel to the principal axis. So after reflection, the reflected ray appeared to diverge from the principal focus. So now look at this diagram carefully. Actually here convex mirror diverges the parallel beam. Concave mirror converges the parallel beam of light. Convex mirror diverges the parallel beam of light. So this is called the virtual focus. Actually here we will get the virtual image of infinite object. Suppose if the object is situated at infinity, the rays starting from infinite object. Okay, so those rays are almost parallel. Okay, so here parallel beam actually that is starts from infinite object. Okay, so here we will get the real image. At this point we will get the real image. So real image means image that can be caught on the screen. We can touch that image. That is a real image. So at this point we will get the real image of infinite object. So this image can be caught on the screen. So we can touch that image. But here we will get the virtual image. We can't able to touch that image. Image that cannot be caught on the screen. That is virtual. We can't able to touch that virtual image, but we can touch the real image. Real image that can be caught on the screen, we can able to touch that image. That is a real image. Virtual image that cannot be caught on the screen, we can't able to touch that image. That is virtual image. Okay. So this is actually real focus. This is virtual focus. Okay, what is the meaning of principal focus? Principal focus, that is a point. Principal focus, that is a point on the principal axis where the parallel beam. Principal focus, that is a point. This is principal focus. This is principal focus. That is a point on the principal axis where the parallel beam of light converges or appear to diverges. Converges or appear to diverges after reflection from the silver surface of spherical mirrors. Okay, so that is the meaning of the principal focus. So the terms connected with spherical mirror, that is very important. Terms connected with spherical mirrors. The first term, that is pole, the symbolic representation is P. What is the meaning of pole? Pole is the center of a reflecting spherical surface. Okay. And the second term, what is that? The center of curvature. Center of curvature. The symbol is capital C. Center of curvature. Center of curvature is center of the sphere, but the given mirror is apart. Center of curvature is center of the sphere, but the given mirror is apart. Okay. So the next one is the radius. Radius of curvature. The symbolic representation is capital R. So radius of curvature, what is the meaning of radius of curvature? That is the radius of the sphere. Radius of the sphere. Actually, the distance from pole to center of curvature. This is the radius of curvature. Distance from pole to the center of curvature. So this is the radius of curvature. So radius of curvature, that is the radius of the sphere. Radius of curvature is radius of the sphere, but the given mirror is a part. Given mirror is a part. The symbolic representation is capital R. And principal axis. Principal axis means that is a line. Principal axis is a line that is passing through the pole and center of curvature. Principal axis means a line passing through a pole and center of curvature. So that is called the principal axis. Okay. The next very important term, that is principal focus. Principal focus. What is the meaning of principal focus? Principal focus, that is a point on the principal axis. Principal focus means that is a point on the principal axis. Point on the principal axis where the parallel beam of light converges or appear to diverges. Converges or appear to diverges. So principal focus, that is a point on the principal axis. Point on the principal axis where the parallel beam of light converges or appear to diverges. Appear to diverges. That is the meaning of principal focus. And the next very important term, that is focal length. The symbolic representation is small f. Okay, so focal length is the distance from pole to focus is called the focal length. Actually, radius of curvature is twice the focal length. For example, radius of curvature PC is 4 cm. The focal length is exactly equal to 2 cm. Focal length is half. Focal length is half of the radius of curvature. Suppose the radius of curvature is 10 cm. What is the focal length? That is 5 cm. Okay, focal length is 4 cm. What is the radius of curvature? Focal length is 4 cm. What is the radius of curvature? That is 8 cm. Okay, so radius of curvature is twice the focal length. Focal length, that is half of the radius of curvature. This point is also very important. Okay, so focal length is the distance. Focal length is the distance from pole to principal focus. The distance from pole to principal focus is called the focal length. Okay, so these terms are very important. So concave mirror, that is also called the converging mirror. Why a concave mirror? That is also called converging mirror because it converges the parallel beam of light. So convex mirror, that is also called convex mirror. That is also called the diverging mirror. Convex mirror, that is also called the diverging mirror because it diverges the parallel beam of light. So what is the meaning of concave mirror? Concave mirror is the light gets reflected from inside the surface of a part of hollow sphere. Light gets reflected from inside the surface of a part of hollow sphere. That is the meaning of concave. Cave means inside. So convex mirror means the light gets reflected from light get reflected from outside the surface of a part of hollow sphere, that is convex mirror. The light gets reflected from outside the surface of a part of hollow sphere, that is convex mirror. Okay, so the statements are very important. The spherical mirror. What is the meaning of spherical mirror? A smooth reflecting spherical surface. A smooth reflecting spherical surface, that is spherical mirror. That is of two types, concave and convex. Concave means if the light gets reflected from inside the surface of part of hollow sphere, that is also called converging mirror because it converges the parallel beam of light. So another one is convex mirror. If the light gets reflected from outside the surface of part of hollow sphere, that is convex mirror. That is also called diverging mirror because it diverges the parallel beam of light. Okay. Right. Okay. So thank you.